Je peux faire. C'est le truc Zoom, on le voyait encore pour les gens. C'est sûr que là, quand je vais me lever, moi, on verra plus ma caméra. On va voir le mur.
Bon.
C'est juste un complément.
Sans toxicité, je pense qu'on est plus là pour ton discours que ta face sur l'écran.
J'ai d'autres trucs à notifier ici. Il est 10h03. On va commencer, j'imagine. Tu peux me dire si le son fonctionne? Okay, so I'll start. So welcome everyone. It's nice to do a live physical event. So this will be a workshop, as you can see, on web application firewall, or often called just simply WAF. So this will be an interactive presentation. So I'll have some slides, but there is some instruction also to do by yourself some of the exercise. So I'll give plenty of examples, but we'll focus on at least 4 exercises. So without further ado. So who am I? So I'm a security engineer for ServiceNow. I used to be working for GoSecure as a researcher. I have interest in multiple things in security, mainly application security, anything related to web application, crypto, and static analysis. So one of the projects I've started is Find Security Bugs. It's a 10 years old static analysis tool that is focusing mainly on Java and Kotlin language. So if you're interested, there. Now, for this presentation, I divided into 5 main categories of WAF bypass, plus an introduction to begin with. And those categories are general categories. So I'll give plenty of examples for each. But I think the main goal of this presentation is that you remember the general category. So if you ever encounter either a middleware that is a WAF, reverse proxy, maybe a bunch of regex that are inside of an application, maybe an htaccess file that is blocking some path or some parameter, it will be the same pattern. So you'll have some tool to think, okay, what are the type of ways that I can attack this problem? And often it's because people will focus on one aspect of it. So often people will focus only on encoding, but we'll see that there are sometimes alternatives that are easier to use to bypass some filters. Now, for this workshop, I'll give you a good 30 seconds if you want to take note, and we'll do the exercise. I'll show again the repository URL. But basically, at this repository, you'll find all the code that I'm running for the application, and you'll also find link to the slide that I'm showing. So I'll show you. And so the slides are a summarized version of a mini website. So this is all the content of this presentation. So I'll zoom a bit on it, but you'll see there's quite something. So for each categories, there will be some material and then some step-by-step instruction for the different lab. Here, you'll see a different payload, a few questions that I'll be asking. So you can either follow along the slide or this, but really for the exercise, you should be referring to this small website. That is the second link here. So, but wait until I tell you that we're doing an exercise. But for now, if you have a, okay, I'll need to reopen the slide. Okay. But that's for later. Now, just some quick definition to make sure everybody understands what is a web application firewall. So often they are just called WAF. So you'll probably hear this for the rest of the presentation. Their purpose is either to filter some requests, monitor, so maybe not block everything, but sometimes raise alert that there is potentially an attacker exploiting your web application, or even to block requests. So some traffic. So the WAF will be installed or deployed between the clients. So this will be your external user on the internet, and the backend will be your application. And WAF, well, this is represented as a different server or application. Sometimes it will be as just a different application running on the same machine. Sometimes it will even just be a component inside of the web framework that will do some filtering for potential matches. No, I think we're okay. And I'm using the webcam for Zoom for the sound. Okay. Yeah. Yep. Okay. Some of the vendors. So, what are some examples of WAF that you can encounter? So, usually when people deploy manually WAF, these will be sometimes just a module or a feature that they will enable on their load balancer. So this is the case for F5. But if you want to just start and have some level of protection on your web application, you can deploy freely mod security or Maxi. Unfortunately, mod security is not actively maintained, but there's already a good set of rules. But we'll see that are some edge case that we can exploit on mod security today. So I'll show some example. But almost all cloud providers, so Azure, AWS, that's the red logo at the bottom, they have their own WAF. And the clear advantage of having WAF in their infrastructure is that if there is some new vulnerability that come out, so let's say for Log4Shell that came out last year, you can provide a quick response to block some payload automatically. So if you can see that there are some automated scanner and exploits that are being shared to test those exploits, you can try to find a pattern and create a rule that will protect all your clients at the same time. So because not all clients can update at the same speed, it's a way to provide a quick response. So the first segment, you'll see it's going to be maybe too obvious or too simple, but often people forget about it. It's simply if some specific path or parameter is blocked or some keyword, the first step should be trying to find alternative. So an example of this is on WordPress. So many cloud provider will block some endpoint because they leave too much information about the user, including some username, some emails. So this is the case for WordPress. So they will try to block the first path, so ending with WP v2 user, but often they forget that there are plenty of other ways that you can get the same information. So you can request the author page. You can call the same v2 user endpoint using the REST route parameter. This is because WP-JSON is just URL rewriting to the index page with the REST route parameter pass. So in the end, it's the same endpoint being accessed, but different URL. Alternatively, even if you have some plugin sometime installed, the information can be accessible elsewhere. So if you have a WordPress.com website, it might not be accessible directly through the /user endpoint, but with the Jetpack plugin that is enabled by default, your user list will be accessible also through this route. There are also some other alternatives explained in this article, but they will use some techniques that I'll explain later. Now, when it comes to XSS, you can simply try to find some alternative tags. So this will be much more easier if it's just some regex that was implemented by a developer to quickly patch a specific case. You'll easily find some alternative tag. If you're looking to bypass HTML sanitizer that is well maintained, it will be more complicated. But try to find alternative tags or attributes. So I'll give some example here. So instead of using a script tag or an image tag that are the typical XSS payload for testing, try to use SVG tag, video tag, or even in this case, one of a researcher found that using details along some on-toggle attribute, but it also mixed with some case change to some of the property, and it adds new line. So it's a combination of many patterns, but we can see that using alternative tags can often easily bypass some filters. Now when it comes to SQL injection, there are some tables that will be blacklisted or some keyword that will be blacklisted in almost all WAF. So it's unlikely that your normal user will submit information schema .tables or .columns unless it's a forums talking and discussing about SQL. So it's pretty safe to block those complete keywords. So if it's just a list of keywords that is blocked, try to find some alternative table. So often it will be either just other tables. So here table constraint doesn't include just table names, but constraint related to table, but you'll be able to find table name this way. Often statistic table. So these will either be provided by the DBMS itself, or sometimes it's some a module that was installed with the framework that will create some table for statistic, and you can target those to get some enumeration and find some hidden table. Now I have a question for you. Does anybody know what underscore migration history is? This table is doing. So it's no longer relevant since a year and a half, but it was the table used by entity framework for .NET. I think it's entity framework, something like that. Now it was renamed to underscore EF migration history, and it no longer has a special column that was model that had the complete table model of the ORM gzip in one column. So you used to be able to target this table and extract the list of column and table in 1 week. And it's actually pretty rare. I didn't see it in other ORM. So, and the last example, this is for Oracle. So all underscore tables will be blacklisted in all WAF, if not most. But tab statistic also include table names, so you can try those if only specific table name are blocked. For the exercise of this one, it will be in the next at the end of the next section. So I've included one exercise, but generally the methodology for finding those alternate keyword or table is just digging through the documentation. So I didn't want to do an exercise where you just have to do some Google search for some framework, because it can be time consuming and it's either you find it or you don't. But I found a way later on to have an exercise on it. Now encoding, this is probably what people often think first. So they think, okay, we have a web application firewall, it's detached from the application. So it doesn't have all the context attached to the request. So maybe the application is doing some additional decoding, and then I can do some transformation to some of the parameters that I'm sending to the application. And the idea is we're not sending a different parameter, but we're going to encode it slightly differently, that the WAF will not be able to see that it's actually a keyword that it has a blacklist, because it's slightly encoded differently. So one example is changing case mapping. So in Unicode, all basic ASCII character will have an uppercase and a lowercase version of those. And if the application in the end does some lower case operation or uppercase, or some insensitive operation, then you can just change the case of the keyword, and maybe you'll be able to bypass the WAF. So what do you need to look for when you're reviewing maybe some regex or some configuration? Look for case insensitivity. So if you have a regex in your WAF configure, make sure it has, for example, in PHP, you would see the E identifier at the end saying, okay, if this pattern is present, but regardless of the case, it would be like this. In Python, you need to add an additional flag. And in Apache HTTP server, you need to add those NC. Otherwise, it will be strict case mapping, case validation. So case mapping is the operation of finding the uppercase equivalent character. But yeah, so make sure if you are looking at or investigating at some filter that insensitivity is enabled. URL encoding, this is something you can encode and sometimes double encode. This will be possible because some component will sometimes do encoding that is unnecessary. So there is this case here for an exploit that I don't know about, but the idea is that the component that is trying to load a file on disk maybe is not sure about the way that the parameter will come to this component. So it's doing an additional URL decoding that the web container already did. So if you have a component that, or one or two that are doing additional encoding, then you can potentially do this. And sometimes it can be really deep. So if you have the component that is a reading file that is doing unnecessary URL decoding, then you can do this. We'll have the case here for output look for an XSS pattern. So here it's just XML tags that are encoded to bypass potential filter that will look only for script with tags. But because the application is doing some unnecessary decoding, we can do this. Now some XSS is a vector where we'll have plenty of opportunity, because depending on where the values are placed in the page, we'll be able to encode sometime our value with additional encoding. So if it's present either in an attribute or in an XML tag, and it's read by JavaScript, then you can encode it with XML entities, because when it's going to be read from the DOM by JavaScript, automatically those entities get decoded. So this is a behavior that happens client side, but the idea is that your WAF would not necessarily look for XML entities encoded parameter and think that it will be safe even though it's reflected as is. So you can do entities with name. So here it's lower than, so starting character for XML tags or HTML tags. But you can encode the same character with X value or the decimal value. 60 in hexadecimal is 3C. If it's present, your value end up in JavaScript, you'll be able to use some slash encoded escape value. But basically, the way to represent this character is pretty rare because it's going to be either in JavaScript or some type of scripting. If you're trying to just bypass some specific characters that are filters, so maybe single quote or double quote, you can use sometimes function that will provide the same result, but without using a single quote directly. You'll be able to enumerate those same X value, but as parameter to this function. So this is not exactly encoding, but I had to place it here. Now, another avenue is Unicode encoding. So this will apply heavily if you have some file that is being uploaded and your file is being blocked because some analysis is done to the file, or in some case to the body of requests where you can specify a specific encoding. So UTF-7 is mostly historic because Chrome, I think since 2009, doesn't support it anymore, and most browsers won't support it. And many web frameworks simply don't support this content type anymore. But we still have UTF-16, the little endian and big endian version that are still available. So this means that, so the particularity with UTF-16 is that you need to place some what are called BOM or byte order mark. So this is the first 2 bytes or 3 bytes, I'm not sure. So that will define what encoding is being used. So most applications will be using UTF-8 by default, but if you specify those specific marker, then you'll be able to encode it in UTF-16, LE or D. So every character will take 2 bytes. So for a WAF that is doing strict byte comparison, so thinking that it's UTF-8 string, it will think that these are no byte separating every character. So most of regex will fail. Yeah, and UTF-32, pretty rare, but it's also a fixed length character length. Now, normalization, this is something, again, that is rare, but there are many cases when it can be helpful. So, and one example, normalized character is basically you have some Unicode character that will have an equivalent version that is the simplified version. So sometimes it's to cope with limited support of Unicode, so it's being simplified for storage, for example. And one example is the default mode. I forgot the exact name of the collation or the configuration, but in SQL Server, if you store this character, so ff.c, with the default collation, it will convert it to simply the regular XML tag character, so lower than character. So this means that on storage, you'll send this to your database, but once it will be fetched, it will be an actual XML tags. So this is something to test. It will depend mainly on your database configuration and the type of field that you're using, because some type of nvarchar will not do this, but it's really depending on the collation configuration. And by the way, so in the detailed website, you'll have more reference and more detailed explanation. So you'll be able to find more detail. So now we're ready to do some exercise. So because it's a workshop. So for the first exercise, if you're not fully ready, you can just click on the link in the slide, and you'll get kind of a level up. So I'll give you a good 15 minutes to start with, just to find the URL, get to it. I think most of those can be done from the website, mobile phone even. So what you need to look for, so these are not proprietary or commercial WAF use. These are simple PHP function, just because it's easier to describe, but you'll see in later exercise that we'll be using some actual WAF use in production. And what you need to think about is we've looked at finding alternative keyword or elements, and we looked at encoding. Now you have 3 forms where you can submit a name. So let's say submit this. It's being reflected in the page. So you need to find a way to do an XSS. But if I do an obvious pattern, so like this, can be read, you'll see that my homemade WAF will block some payload. So you can look at the code in the page. So this is the core element to look at. But if you need more context, you have access to the full source code. If you open the view for source code, so you'll see the complete page with the actual code if you want to see the full. Once you're done with one exercise, you can go to the next form. So there are 3 forms to test. And the 3 are not necessarily different difficulty. It's really just different things you need to find, and you need to apply the different tricks that I've presented. So I'm giving you time to open your laptop and find the URL. If you have any question, raise your hand. And I'll be looking for people online at the Discord channel workshop. So, but be patient. I'll probably respond within 10 minutes. So, yeah, good luck. Yeah. So this is the main repository you need to look for. And you'll get the slide and I'll paste it in the Discord. So were you able to get it? Donc, si vous voulez voir le site, okay, perfect. Here we see the first exercise and do it even on a mobile phone. So, so basically, if you open the WEF workshop on its extreme workshop, and you'll find the slide, and so that's a lot of things to follow, but WEF workshop, open the slide, and then whenever we'll encounter we're at slide oops, too far. Actually, it might just be easier to type directly the exercise URL. So it's 3 forms, and for each form you get some reflected value in the page, and you have just a PHP function simulating a WAF. So this could be a rule configured in a WAF, and you need to find a bypass for each of those. So you have 3.
Yeah. It wasn't URL. What you can see there. Open and capitalize.
Quick question. So does anybody doesn't want to be taken into a picture? I'll be taking a picture. So everybody's okay with that? Okay, good. And try to look very concentrate. C'est quand même plutôt relax les workshops quand tu peux prendre des photos.
Tu voulais-tu que j'en prenne avec toi dedans?
Ah ouais, ça pourrait être
Ouais.
I guess it's not. So let's see.
On which exercise are you? So on this one, look at where some plays it on. See that place inside of so it's good like there's a big vector for this
Yeah, actually.
and this but actually don't start out. So however, the value outside of the experience will be relevant.
Well, you should start with yeah.
Or you can use some specific coding. When the JavaScript will read the init, that will become because it's a
Yeah. Oh, yeah.
Okay, so I'll present the solution for the tree exercise because we have a few more exercises to show. So by raise of hand, anybody found the tree solution for each tree? So at least 2 people, and probably you were very close. So, okay. Open the exercise. So for the first one, you need to understand that square bracket in regex, unless there's a wildcard after it or a plus sign, it's only one character. So this is looking for an opening tags followed by one ASCII character. The issue, and many of you found it, is it's not case insensitive. So for this reason, instead of using this, which is blocked, I can just simply replace the first character by a capital I, and suddenly it's working. Because web browser are case insensitive for tag names. And same thing for attribute names. So this was the first. The second one is a bit more tricky because actually not everything is in this snippet of code. This is just the WAF, but you really need to look at where the value is placed. So when you submit a new value, you'll see that in this profile form, the value is placed. But here, this welcome followed by the name is actually done by JavaScript. So if we look at the code, it's reading the field register name from the profile form. And because we're reading an attribute from the DOM, this means it's a context of XML. I just want to find the field. So because we're reading it from here, it's XML. So if we include entities from JavaScript, when you will read the value, automatically JavaScript will decode those because in the DOM, the actual representation will be decoded. So just to confirm that I'm not saying something wrong. So here, instead of using tags, so this will appear as is in the HTML. So the XSS is not happening here. It's the JavaScript that later reads this this field that will create this XSS. So yeah, another thing I want to mention. Yeah, we'll look at the source just to confirm what is happening. So here, we cannot escape the single quote. at least from what I've, and even if you would use a backslash, you don't have any control with the value that would follow. So if you thought about this was a great idea, but really the solution was to encode everything, and because it's JavaScript context, then everything's get decoded. Now for the final one, the regex was probably misleading because it's not so much about the regex or the validation function. Here I wanted to show that often you need to look at implementation difference between what is validating the request and the application that is receiving the request. So sometimes you'll have something that validates the URL, but later when it's passed to maybe a HTTP library, it will parse the HTTP URL differently. So this is something to think about. Here it's a much more simpler case where the validate input is using _get, but actually the application itself will reflect the request. And request in PHP is both get and post parameter. So the idea was, instead of focusing so much on encoding it differently, just look for another vector, and here it was switching to post parameter. So I'm just going to switch this form and changing from a get to a post. And what used to be blocked now should trigger an XSS. So as simple as that. So that's the way I found a way to do an exercise on finding alternative keyword or path without having to search into documentation for a known application. Now back to the slides. So we saw finding alternative keyword and encoding. Now I've done a segment specifically on SQL injection because it's one of the core vector where people will try to find WAF bypass. Sometimes regex will include some spaces, and in SQL you'll find plenty of alternative character that will do a space. So tab will often be also accepted as a keyword separator, but there are plenty, and actually I even cropped the SQL Server one from the original source because it was there are 3 times more character that can be used as a white space. Also, few tricks. So you can use comments. So this is not a single character, but it's going to do the same thing. So you can include empty comments or comments with misleading keyword inside of it, maybe to try to fool the WAF. In MS SQL, you can add some square bracket around a table name, and you can put columns between quotes or double quotes. In Oracle, you can encode table name and column in hexadecimal. So this is pretty helpful because this will not be a byte representation. It's really an ASCII representation. So as you see it, this is the way it's being sent. And now this part is important because this will be the next exercise. So this is something that was found by the same researcher, so Roberto Salgado, that documented this behavior that in MySQL you could use 1.e. But one of my colleagues, Marc-Olivier Bergeron, found that this could apply to bypass the AWS WAF. And I've looked at it and I said, oh, this must be a way to bypass also lib injection that is used by mod security and plenty of WAF. And it is. So the idea is that MySQL, when it will see, when it will parse your query, it will tokenize every keyword and it will go through from left to right. And when it will see a scientific notation, so one exponent or any numerical value exponent something, it will start to parse it as a numeral or literal value. But if the character that is following the E character is not numeric, it will simply just cancel the operation and the 1.e is simply ignored. And So for this reason, now we can start to add some what.e to prepend all of our keyword, and this will fool lib injection. Lib injection is doing some advanced context analysis where it tries to see, for example, when you place a single quote in your parameter, it will say, okay, possibly this is starting to be out of the context of a literal, so it will try to find in this context some specific keyword that are SQL, and it will try to see if it's a valid SQL query that you're injecting. So and it has all the keyword from different DBMS index in the engine. But with this, it's easy to fool the lib injection that it will simply not see as MariaDB or MySQL would see it. So, and this will be the next exercise. So for this one, there will be a live instance. It's possible through mobile, but you'll see it might be pretty hard to always retype through the URL. So this one, it's not a form, so you'll have to find the input in the URL that are vulnerable to SQL injection. Actually, there are two parameters that can be placed in my custom application, and both are vulnerable. So you have two vector. So I'll give you one. So here there's this genre filter where you can specify the movie types, and if you add a single quote to it, this will raise an error and return nothing. But if I start to add some keyword, let's say union, oops, something, then you'll get a forbidden page. This is the mod security module from it's either a Nginx module or a Apache module, and the request will not even reach your application because it's appearing too risky for mod security. And mod security is a combination of both a set of regex and also lib injection. And lib injection is really going to be used when you have payload that simply don't have SQL keywords. So if you're just trying to do single quote space empty string equal single quote, just to do a always true condition, lib injection will find those because it's a contextual parser that is able to find SQL patterns. And this is the type of condition that we want to find in the application. So try to inject into the parameter and confirm that there's an injection. And then try to do some always true condition to, without specifying something empty, find something that is always true. So I'll give you good 5 to 10 minutes, and then I'll explain you the next step. So try to find a pattern that is blocked, and then using the scientific notation, try to find a bypass. But don't go too far with the first exercise. So don't try to do a query that is doing a union and adding some table name. Just do a condition that is always true, because you'll see that the final payload will be quite complicated. So, yeah. So for people that are not sure, you need to find first SQL injection vector, and you'll be blocked by mod security, and try to find a bypass using this specific technique. Oui.
Ce genre d'affaires-là, c'est pour toutes les lois, c'est juste comme, admettons, un particulier.
C'est sûr qu'il va y avoir des comportements différents. Puis ça, en fond, ça a été reporté l'année passée à AWS, avec eux, ils ont corrigé. Mode sécurité, la réponse était qu'il fallait augmenter le niveau de criticité qui n'est pas celui par défaut.
OK.
C'est sûr qu'il y a des side effects. C'est comme 3 niveaux de paranoïa qu'il appelle dans mode sécurité. Si tu l'augmentes au dernier niveau, oui, cette partie-là va être bloquée. Mais la moitié de tes requêtes aussi vont l'être. Tu vas avoir beaucoup de faux positifs. Mais c'est sûr que ça peut fonctionner sur différents WAF
OK.
qui utilisent lib injection parce que lib injection est utilisé par beaucoup.
OK, dans le fond, c'est ça. C'est que
Ouais. Et puis sinon, oui, non, ça dépend d'un à l'autre. Puis dans le fond, le behavior a été également reporté à MySQL puis MariaDB. Fait que dans les dernières versions, ça devrait être possible.
Sauf que combien de gens ont une nouvelle version?
C'est ça. Ouais, ouais.
OK. Non, c'est
Puis-
juste, moi, je suis côté criminel, je ne suis pas côté de ce bord-là.
Ouais.
Ça m'intéresse toujours de l'autre. C'est comme l'intérêt criminel plus que
Ouais.
ça. Fait que c'est encore vivable, dans le fond. Tu peux, tu peux encore l'utiliser comme
Ouais. Puis dans le fond, c'est pour illustrer là, que, mettons, si c'est une application qui n'est pas à jour, là, tu te dis, OK, ben, mon cloud provider, il y a un WAF, je suis correct.
Sauf que
Quelqu'un qui est vraiment motivé et qui le voit comme une.
c'est pas potentiel.
C'est ça, ben, lui, il va pouvoir peut-être investir du temps pour. Mais le WAF va faire, c'est sûr, son job, même avec des edge cases comme ça, pour des gens qui roulent des scans automatisés pour trouver les vulnérabilités sur toutes les drupals et tout.
Ouais.
Ça, c'est quand même, c'est un edge case, puis c'est quand même relativement difficile à appliquer là, dans les sites, dans le détaillé. Je montre comment les payloads qu'il faut mettre, mais c'est quand même beaucoup plus d'efforts. Déjà que trouver l'injection quand tu as un WAF, c'est plus difficile. Tu peux plus rarement
Soit
utiliser.
vraiment motivé, il faut qu'il soit un calibre plus
Ben,
motivé que la norme.
Ben, c'est que le WAF va t'aider aussi pour ralentir la détection. Parce que, par exemple, un scanner automatisé, lui, il ne pourra pas avoir des requêtes toutes faites qui vont vraiment comprendre facilement. Hors de tout doute que, mettons, si tu injectes retourne-moi la version du DBMH, c'est sûr. Mais là, si tous ces mots-clés-là sont bloqués, là, comme l'exercice en ce moment que les gens font, c'est vraiment juste de confirmer avec un enlever qui s'apparente à une injection script. C'est pas confirmer hors de tout doute. Le WAF, c'est sûr, qui ralentit la façon.
OK.
And quick reminder, so there is the application that you can test directly. There is a slide, but there is also this website which includes step-by-step instruction for the different labs. And it's really the detailed version. So you're probably seeing less than 50% of the content on the slide. And if you want to run the instance by yourself to have some basic information on how to run and set up the application. Hey, salut. Bon, et voilà. Ouais, surtout, justement, les photos là, sont comme, ils datent d'il y a 4 ans.
Ah oui, on veut.
Ouais, mais
Ouais.
mais un
Je suis
de
pas
vous
capable
devant
d'être.
l'écran, pas moi, lui.
Ouais, je vais remettre les
C'est
slides.
plus professionnel, comme ça fait plus, je présentais que je suis devant un bureau.
Ouais. Bon, je vais mettre de quoi, là. Écoute, sérieux.
Trouve la bonne slide, là.
Là, ça va prendre des bonnes photos pour le site web. Là. Ça fait 2 ans qu'on n'a pas de nouvelles photos. OK. Okay, I'll do the demonstration for detection and the advanced exploitation. So, and you'll have a few more minutes to complete the exercise, and then I'll continue to the next module. So for detection, so you either add, yeah, I should be able to zoom. Okay, either have the general parameter here where you could do some injection, and so this was blocked. And if you have installed the Docker locally, one advantage is you'll be able to see exactly. Am I able to zoom? Yeah, you'll be able to zoom to see exactly which rule is being detected. So is it part of the regex core rule set, or is it lib injection that is detecting this pattern? And this just or with single quote, this is the keyword or is not blacklist. So it's really lib injection that see it as a SQL injection pattern and will block it. Here, for detection or to bypass the filter, simply adding this scientific notation before one of the literal, but typically you can add it to any function name or keyword that you're using. Because this will simply be ignored by MySQL, we can add this, and suddenly we have a condition that is always true, and we can see that we get all the movie from here. Now for the advanced part, it's pretty hard to build. That's why I've included the complete payload. But we're not going to be able to use union. So this is something that you've probably saw that even though we're using 1.e, because mod security has some aggressive rule regarding if you have union keyword followed by select, it will be blocked. We won't be able to use union, but we'll be able to use select from inside of this query and do a Boolean condition to extract specific character. So this is something we call blind SQL injection. So, but no, it's not exactly blind because you still have an oracle, but basically the complete query that we're sending is something like this. So we're extracting the ASCII character from a substring. So substring is to extract one specific character. From here, we're selecting. So I should have started with the middle part, but we're extracting the first password from the user table here. Then we're doing a substring on the password to extract just the first character. And then ASCII is to convert the ASCII character to a numerical value, and then we can compare it to an ASCII. And this is the actual query that we want to execute. This is the obfuscated version in order to bypass the WAF. So you will see that there is plenty of occurrence where we'll be referring to this notation. And again, this doesn't need to be a 1. So if you see a hardcode regex that look for this in some new rules, you can just change this to 2 or any value. So you'll still have 5 more minutes if you want to do this. So try to just execute this inside of your query or the parameter and change the 70 to something else just to see that there is a true or false condition. And one important note, you need to add a single quote before the or if you're using the vulnerable parameter on the first page. I didn't add the single quote just because the syntax I think would have been just seen as one literal. So, but there is a single quote missing here. And you'll be able to do the same thing if you're looking at the movie detail page. There is an ID parameter that is not only numeric. So here you don't need to do use single quote. So same thing will apply. So here it's forbidden. But if I try something like this, I'm able to bypass just because I've put the one at en followed by a literal volume. Yeah. So, and I was discussing this with Vicky. So it doesn't mean necessarily that the WAF has no value, even though it has an edge case currently. So for an attacker, if you have a complete website, you'll have tons of parameters. So all header, all post parameter could be tested for SQL injection. If you're running a scanner will be efficient at detecting SQL injection if they can pass some long query where they can confirm for sure that there's SQL injection. Scanner usually don't use sample conditions that are likely to return different length of page. It's easy for a human to detect that, okay, this is we're pretty sure it's an SQL injection. But for scanner, usually they'll need plenty of keyword. So with this WAF, in a real context, a real application, you'll still slow the attacker because it will be pretty inefficient at finding which vector are present for SQL injection. So you still have some time to do this exercise, and then and the next exercise is going to be a very similar application, but you'll see that we'll be able to bypass the WAF completely, with a much more simpler pattern. Okay. That's fine. Ouais, ben en fait, souvent, ouais, c'est très facile. Parce qu'en fond, la WAF, il ne sait pas ta requête, tu l'envoies où. Par exemple, une page qui n'a même pas de paramètres. Si tu ajoutes un paramètre toto égal avec un apostrophe unit select, lui, le WAF, il trouve aussi ça a l'air d'une attaque même si le paramètre n'existe pas. Okay. C'est une page forbidden ou un error system, spécifiquement quand tu mets des mots-clés qui sont une attaque. Comme un pentester va le détecter dans les premières minutes que, OK, il y a un WAF parce que moi, vraiment, j'envoie quelque chose. Fait que là, vraiment, pour chacune des attaques qu'il va vouloir faire, je pense plus. Qu'est-ce que je peux faire? Quels mots-clés sont bloqués? Okay. Ouais. C'est sûr que page forbidden, théoriquement, ça peut être plein de trucs.
Oui, mais généralement, ça donne un indice de
c'est ça. Surtout des trucs que tu peux te dire, OK, ben ça aurait au moins dû passer, c'est pas censé. Ouais. C'est une erreur interne, là, juste mettons. mettons, tu soumets ton nom, tu modifies ta description de ta bio, puis tu mets un pattern d'histoire de gestion. Au moins, s'il n'y aurait pas eu de WAF, ça aurait peut-être retourné le contenu tel quel.
OK.
Mais ça, c'est ça. Oui. Oui.
Maybe that is it. That's not. It's weird to think of it. Yeah, it's Firefox. Start with A, right? Oh, so we use 61. Yeah, it's the mid part. So what I did is convert 1 to a 2. So now the 8 characters. Oh, so if I change that to 16 for this. 1 to 62.
No, exactly.
Or is it quick? So if I do change the constitution, the 6,
Okay, so I'm going to continue to the next section, and I have some bonus information for the SQL segment. So the labs include all instruction for the exercise, but if you look at the material section, you'll see that it's the content that I mostly presented through the slide. And at the end, is it here? It's in encoding material. So there are 3 tools that I didn't mention in the slide, but can be helpful in many contexts. So CyberChef, it's a web-based encoder, but it's really easy to just encode on the fly a few things if you don't have Burp or an encoder. And even then, it's better than most encoder in most proxies. So the big advantage is that you can change encoding. So you can specify your input and then drag and drop some encoding. So you can do entity encoding and then URL encoding of the final payload, and then you get the result. If you want to be efficient in Burp, I really like to use the Burp extension AcVector, and this plugin allows you to use tag to do nested encoding. So you can use basically tags, and you can enable, it's not the case by default, but in the repeater, you can specify those tags. And when you send the request, the extension will transparently encode everything according to the tag you've used. So you don't need to remember the tags. You just right click in your repeater or intruder, and you have a list of encoding possible, but it will just place those tags. So when you're doing some tests and you're just editing one character, doing some tests, it's really nice to be able to just visually see what you're thinking about without having to encode and decode when you want to edit every time. There's another extension. So this can be helpful. I've developed it. It's just a simple fuzzer, and you can add some additional encoding. You can specify this generator. So usually generator is to generate list of items in Burp Intruder. But what I've done with this extension is I'm taking the selection and I'm generating variation for different encoding. So all character encode with XML entities, URL encode, double URL encode, Unicode, special encoding, stuff like that. So if you have a parameter and you want to see what is passing through, you can use this extension. Now, the last thing I want to mention, so this was the solutions to extract one character at a time for the user table using the WAF bypass. But we actually have a team that potentially found a way to do a union select, still using the exponent, but along with some special character, from what I saw, using /escape character to specify some specific byte that with full lib injection. So if the solution ever worked, I'm going to add it to this material. But obviously, being able to do union select is much more powerful than extracting one character at a time. So this was for this. back to the slide. Switching protocol. So the two last modules are switching protocol, which is something part of the HTTP protocol, and it will be very similar to the request smuggling case. So, but we'll only have one exercise for switching protocol because I think it's too much similar to have a different exercise. And as you'll see, it's going to be the same application, but it's going to be much easier to bypass. So what exactly is switching protocol? So switching protocol is a mode or a part of HTTP. So the idea is that from HTTP 1.1, they wanted to support additional protocol. So the idea is that you have a regular HTTP request that is sent. So this is part. And as another, you specify upgrade with a parameter that is the protocol that you want to upgrade to. And if the server return its status code 101, this means that the application is saying, yes, I'm able to upgrade to this protocol. So once this request and response is exchanged, within the same HTTP connection, the following bytes are going to be in this protocol. So this is the way a WebSocket works. So you always need to send a dummy HTTP request that is just to do the upgrade to WebSocket. And when the web server return 101, the browser know, okay, the web server is able to speak WebSocket. So from now on, this communication is now full duplex WebSocket communication. So how this can be used to bypass proxies or WAF is that sometimes or most WAF will simply look at the status code, and if they see 101, they'll say, okay, it was upgraded to WebSocket, so I'll no longer look at what is being exchanged. But sometimes, in rare case, you'll be able to control the status code, because sometimes some endpoint will proxy some request to some additional server, and they will reflect the complete response from the external service, and they will also include some headers and potentially status code. So that's one possibility, pretty rare. Sometimes you'll be able to, on a specific path, control an application. So you'll be able to write some code to the provider or the cloud provider, and you'll be able to set a status code that is returned. And if you're able to return 101, even though you are not going to actually do some WebSocket or upgrade to another protocol, you'll fool the proxy, because now from a malicious client, you can do a request to your endpoint that you have created that is returning 101. The proxy will think, okay, it was upgraded to WebSocket or whatever protocol, so I'll no longer inspect the request. And then your same client keep the connection alive and will send an HTTP request. And this will be passed through the application. And the web server can now honor other requests to other paths of the application. And mod security, NACC, and most WAF will not inspect this type of traffic. So there's a lot of condition needed. And the most difficult one is being able to force a status code being returned on the website you are targeting. But this will be possible in cloud infrastructure mainly. Now, another alternative is HTTP2 clear text. So this is another protocol, because we can upgrade to multiple type of protocol. And sometimes the backend application behind the WAF is supporting HTTP2. And it will have also HTTP2 clear text support. So this means that the application will be able to both receive HTTP1 and HTTP2. The malicious actor will initiate an upgrade to HTTP clear text. So at this time, the WAF is inspecting all header and requests. So if you have malicious post parameter and get, everything is active. But once the upgrade is completed, then the HTTP2 traffic will not be inspected, because the proxy doesn't simply inspect upgrade protocol. So this was found. So the credit to the researcher is in the detailed website. Yeah, I thought it was a duplicate from the previous one, but it's almost the same thing. So the proxy need to honor 101, and in some cases, I didn't mention it, but it's important. Like there are some old version of Varnish and some proxy that simply didn't honor a 101. So that means as soon as they would see upgrade WebSocket, they would simply stop to inspect following requests. So this means that even if the website would return 200 OK, then it would simply not inspect. So it was found in a couple of proxies, but these have been patched. If the proxy is aware of upgrade and honors 101, then this will work. Will still work because there was an actual upgrade, and often proxies don't support all the upgrade protocols, so they will not inspect all requests. So this is the next exercise and last one. So you'll see the application is pretty similar. Oops. Open it in the new tab. Okay, so it's the same movie application. It's also vulnerable to SQL injection, but here don't try to use the exponent. You'll be able to use an easier exploit. So if you go to the detailed instruction, there is this script. So you won't be able to, if we're doing exercise from your smartphone, unfortunately, you can from now, but there is the script H2C smuggler that allow you to specify, this is just for testing, but when you'll be able to, you want to actually do the inject or smuggle your own traffic, you have always two URL that you're specifying. The first one is the URL to which is doing the upgrade. So this is just a dummy request. Usually the root page will work. And then the second one is once the upgrade is done, you'll be proxying additional traffic. And this will be done over HTTP2, but through the HTTP1 connection. So the same TCP connection that was open. And this technique, so again, the requirement is that your backend application need to support HTTP2. And this attack vector can bypass mod security, NACC, and multiple other WAF. And it's pretty easy because you don't need to think about adding some special character encoding. You're simply bypassing entirely. It's a spot that is a blind spot from the WAF. They are simply not inspecting this part of the traffic. So first part, detect that NACC is blocking all traffic. So usually NACC, the way that it's used in production is that there will be some training part where you're sending some real traffic to your application, and it will add some exception to some parameter that need special character, but everything else will be blocked if you have some special characters. So just adding a single code will be blocked by default, but with some training with NACC, you can have a working application with the WAF. Here, to show that it's really working, I've configured NACC, but with no training, so it's blocking all parameters that include some special character, including tags and single code. So, and NACC is not returning a forbidden page, it's returning a custom page. So when you see NACC says no, this means that you've been blocked and it detects a malicious character. But with the smuggling through HTTP2 clear text, you'll see that you'll be able to send your own request and you'll be able to exploit the SQL injection this way. So good luck. So the script can be found on the repository. So if you look at HTTP2 clear text, the script is there. If you Google it, you'll find the official repository for it. The tool is uh, not so much intuitive, but a bit verbal. So you'll get the response from both requests when you're doing some tests. So always look at the last part of the output to see what was the result. So good luck. So we have the next 20 minutes, and then I'll go through some demonstration. And you have some snippet of detecting and bypassing the WAF. You have some extra challenge where try to just extract the MySQL version, and I didn't include right away the answer, so I'll show it in 15 to 20 minutes. Je suis content du format de la longueur. Là, des fois, c'est jamais trop bien. Puis, ça, souvent, c'est des workshops, des fois, ça fait 3 heures. C'est beaucoup d'exercices. Là, je sais pas. On va prendre juste les meilleurs ou les plus représentatifs. Ouais.
C'est pas non plus trop difficile. Non, pas trop facile.
Non. Non, le dernier. En fait, c'est cette semaine, là, je sais comme. Ah, il est. C'est tout le temps ça, des fois, quand ah, j'ai oublié d'installer. Je vais les déployer. Comme ça, les gens n'auront pas besoin d'avoir Docker.
Yes. Yeah.
Okay, I'll show the solution for the last exercise, and then I'll do the final slide, and you'll get the bonus 2 minutes to choose if you want to leave or finish the exercise. And if you have questions, I'll be there until the end. So I don't know if it's big enough. So the idea was, okay. The first step is always to test if HTTP2 clear text is enabled on the backend. So you can do this just specifying -t at the end with the H2C smuggler script. This, okay, let's see. Console. Here we can see there's some TLS warning, but here it's saying success. Yeah, it can be turned off. So this means that the upgrade was successfully working. 101 was returned, and then we could have kept the connection and pass additional requests. Then the following URL that we're specifying, this is something that is tunnel true to the application. So actually, you'll be able to specify hosts like localhost or anything. You already have a connection established with the backend application. So you won't be able to access maybe an internal microservice that is not on the same container, but you can specify maybe a different host, different port, but it will be with the active connection. So here I'm using the same host here. So in the output, you'll get 2 requests. So this is the end of the first one, and then you'll see that we're requesting / for the second request. So this is the tunnel one. So I'll need to look at the URL again. Okay, so if we would just want to trigger the WAF, this one. No. Okay, the port was 777, so maybe it was a mistake on the slide. So yeah, so if I just specified a single code, we can see the NXC is active. It's seeing the single code in the parameter, it's blocking it. So yeah, and one condition we want to test is just or empty string equal single quote. So I'll put it in here. So since we know that this is passing through, so just we always want to start with something small. That so here I'll just specify the first movie. By the way, this is an old custom application. That's why all the movies are so old. So okay, so here we can see that in the second request, we get the detail page for Spider-Man movie. So just a proof of concept. And then if we are adding or1 equal 1, then suddenly we get all the movie description in this detail page. So inception from everything. So if we want to do complete exploitation, now we're no longer limited to like the previous exercise, we were block union keyword select. Now we have access to everything because the WAF is not even inspecting those query, the HTTP2 one. So here I'm doing a union select on the movie table, looking for here. And with the select, I'm injecting a dummy line that is where all fields are 1. So, and this union is adding this entry to the list. So we'll be able to see all the list of movie, and at the end, for this entry, the title, the ID, all information will be the 1. So now we just need to replace the specific column that is reflected. So here we can use almost anything. And would have been helpful to use a different number. So this way we know where it's reflected. Let's do like this. So now I'll just, why is it this? We try. Okay, I have no idea. So I'll just reuse 111, and I'll pick one at random and see if it's reflected. And here we can see that the second column name is actually the title. So here the add version is reflected. So this was the small objective that I gave you. So, but basically you can do anything. You can select any table at this point. Nexi is not inspecting requests there. So good luck doing this exercise. I'll jump to the slide just finish with the material. Up. So switching protocol. Request smuggling is going to be very similar to what we saw. It's just that I really see a clear difference between the two attack patterns. The two previous cases are often called request smuggling, but the typical request smuggling attack pattern involve having some very confusing HTTP requests where you have two content lengths specified. So early version of this attack, attacker will use two content length header. This is for a really old version of the attack, like end of 2000. So 2008, 2009. And the idea is that the proxy will use the first header, for example, but the backend application receiving the same request would look at the second header. And with this, you can potentially do a request to something that would be blocked by the proxy. So the proxy or the load balancer might have some path that they are blocking because it's internal or monitoring path disclosing some information. Yeah, so, and this is mainly because of an implementation detail where the proxy and the application are doing some different implementation to parse the same thing. So this is more an example where it would be a content injection. So the proxy is probably doing some cache as an example, and here the proxy thinks that it's fetching the index, the test.htm pages, but because the application in the end parses it differently, it will actually respond to a request as if it was requesting a profile information. So it will cache some JSON information as HTML. So with this cache portioning, we have potential phishing and XSS possible. But we can use the same pattern to also do web bypass. So that's why I've separated, because request smuggling are usually used to do other stuff. So trigger XSS on other connection of other people. And there are some various other attack pattern with request smuggling, but it's usually have different implications. And WAF is just one of the aspects. The other one that is more recent, this is a new pattern that was found by somebody, and it was presented initially at DEF CON, and nobody did some noise about it until 1 year later, James Kittle found some additional variation to this attack pattern, and then it became better known. So the idea is that in HTTP1, you have multiple ways to specify the way that the length of the body is. So you can use content length, but you can also use, since HTTP 1.1, transfer encoding chunk. And transfer encoding chunk is when you send data and you don't know the length in advance. So you'll say, okay, this chunk is this length, and then you send it, the data. You'll know when it's complete when you send a length 0. This means, okay, we don't have anything yet anymore to send, and with length 0 followed by 2 new lines, then the connection will be closed. The thing is, what happens if a malicious actor send a request with both content length and transfer encoding? The RFC says that you should be always using transfer encoding, but some proxy didn't honor this. And also what was found is that sometimes you can play on some implementation details. So the proxy is actually using in priority transfer encoding. But let's say I'm I'm placing a tab right after encoding. It will not parse it as a transfer encoding header. So it's invalid. It should have been followed by a semicolon. So the proxy will ignore it because it has some special character. But the backend application, let's say, for example, is Node.js, and for some Node.js allow header separator to be just new line. So you have a ton of proxy that are parsing header slightly differently. And for this reason, the proxy will interpret the length as something, and the application will see a completely different length. And for this reason, this request can be either seen as we're sending this complete chunk of 0 till the end as one data as a post parameter. But if we're interpreting it from the transfer encoding header, then we're actually sending 2 requests instead of 1, where the first one is end right away because we're sending a chunk of length 0, and then it's starting a second request to the admin. So with this type of pattern, you can also bypass WAF if you have some rule in your Nginx where specific paths are blocked. But of course, this is a case where the rules are separated from the application. So if your Nginx is doing some reverse proxy to some other application that will be parsing HTTP differently. So in conclusion, in this workshop, I wanted to show you just the general principle of what are the different techniques to bypass WAF. So I'm hoping that at this point, you know more tricks. And the next time you encounter a WAF, you just don't think about encoding. There are some other vector to think about. So as soon as in the final application there is some encoding or decoding that is done, this is opportunity to add some level of complexity in the request to confuse the proxy. If there is some transformation, so some keyword are replaced or removed by the application, this is additional keyword that you can basically inject in your request to just confuse again the proxy. And instead encoding would be double encoding, stuff like that. Parser implementation is probably the more general description to include request smuggling, but also URL parsing. So different language, different platform will often see different protocol differently. So it's really looking at those differences and looking at the implementation that they have done that you can leverage this. WAF is not a silver bullet, so you'll not end security right away by installing a WAF. But at the same time, I'm not saying you shouldn't install WAF. As I mentioned in the introduction, WAF is a good way if you're a cloud provider and you want to provide some quick response to some new coming attacks. So, for example, Log4Shell or Shell Shock or even any type of web attack that you could think. you can provide some level of protection to make it at least harder for the attacker to find those vulnerabilities. So yeah. And there is more. So you saw a subset. I've tried to include a lot of detail, a lot of reference in the detailed tutorial for the labs, but it's still not everything. So I've included 2 presentations that are focusing on specific topic. So the first one is purely at how you can confuse different paths that will be parsed differently depending on what library and web container are used to create some path reversal attack. The second one is purely on SQL injection. Many of the segments that I present, like the reference, like all the white space characters that can be used in different DBMS, I've extracted those information from this presentation. This is a more recent one showing a more advanced approach to bypass WAF for SQL injection. This is a talk purely on how you can implement a fuzzer to detect patterns that are edge cases of the WAF. So this is the end. So if you have any question, I'll be there until the end, and you have the next 7 minutes to either complete exercise or take a break, prepare for the lunch or whatever. And I'll keep the application running so until Sunday, but keep in mind everything is available at on this repository to reproduce it at any time. And if you have issue running any of the Docker instance, open an issue on Docker on the GitHub. So that's it. Thank you.